Hello and welcome back to our discussion about graphing trig functions. And in this video we're going to progress into a discussion about graphing the cosine. So just as we did when we discussed the graph of the sine function, we are going to use the unit circle to come up with some coordinates that we can use to graph the function y equals the cosine of t. So let's progress around the unit circle, and we are going to count by 45 degrees or pi over 4 all the way around the unit circle. And remember that the x coordinate is the output of cosine of t, where t is the angle measure. As we work our way around the unit circle, we're going to just pull the x coordinates. So here at 0 radians, the x coordinate is 1. At pi over 4 radians, the x coordinate is rad 2 over 2. At pi over 2 radians, the x coordinate is 0. At 3 pi over 4 radians, the x coordinate is negative rad 2 over 2. At pi radians, we have an x coordinate of negative 1. At 5 pi over 4 radians, we have an x coordinate of negative rad 2 over 2. At 3 pi over 2 radians, we have an x coordinate of 0 again. And at 7 pi over 4 radians, we're at rad 2 over 2. And then we're back to the beginning where our x coordinate is 1. Now, if we plot those points on a standard xy graph where our x-axis is really representing our angle measures, our t's, we end up with something that looks like this. Now we kind of have half of a peak, right? And then a full valley, and then another half of a peak. But if we were to continue this pattern, we would see that we end up with a hill and valley kind of thing, just like the sine function. And if we connect those dots, we see that nice smooth curve emerge. And it looks an awful lot like the sine function, except kind of where it is situated, right? Because with a sine function, we began at 0 and went up to a hill and then down to a valley. But here at 0, we are at the crest of a hill, and then we go down the hill into the valley and then back up out of the hill. So we start at a maximum here. So we're going to look at a couple of examples of graphs of a cosine function that has no phase shifts incorporated. And we're going to identify from the graph the transformations and the key attributes of the graph, so that we can write the equation of a function that represents this graph. So because we know that no phase shifts have taken place, we can go ahead and say there's no phase shift. And then remember that the amplitude is going to be the distance from the midline to the maximum. And in this case, we have an amplitude of 4 units. We have no reflection in this case, because if we're looking directly to the right of the y-axis, our graph begins at the crest of a hill, a maximum, and it slides down into a valley and then back up to the crest of a hill. And that is what the parent function y equals cosine t does. So this is not reflected. Okay, so now let's think about the length of the period. And we can remember the period is the length of one entire cycle of a sine function or a cosine function. And in this case, it's easiest to look at the distance between maxes. Go from one max to the next max. And we can see fairly easily that that is 8 units. Okay, so our period is 8. And then we will need to use that to come up with our b value for our function. So we're going to set that 8 equal to 2 pi over b, and then solve for b, and we will find that b is equal to pi over 4. So I can go ahead and put that into the appropriate place in our function, the b position, which is right in front of the t, right? And then we would look and see if there is any vertical shift. And since the midline is right along the x-axis, there is no vertical shift here at all. So we can go ahead and say we have found our function. Now let's do another one like this. So with this example, we're definitely looking at a graph that has been shifted in some way, right? We can see that it has been pushed down, so it's not centered around the x-axis. So when we are looking for vertical shift, we will want to keep that in mind. And remember that it's very helpful when that happens to go ahead and sketch yourself what that midline is. We're going to use that in a second. Now remember that our base function is y equals cosine of t. And so now using that midline, we can determine what the amplitude is. Remember, the amplitude is the distance from the midline to a maximum, and in this case we see that to be 2 units. And we can see that if we're looking at the y-axis, we are definitely looking at something that has been reflected because we're looking at a minimum on the y-axis instead of a maximum. So we want to go ahead and add a negative to denote that reflection. Now when we're looking at this graph and trying to determine the period, remember we're looking at the distance between the maximum values. So I can look at that and determine that it's going from negative 2 pi all the way over to positive 2 pi, which is 4 pi units. So that will be our period. And remember that I need to use that to find the b value for my function. So 2 pi over b is equal to 4 pi, which gives us a b value of 1/2. So we're going to go ahead and put that in the appropriate part of our function. And then we are going to look and see how far this graph has been translated vertically. And you can tell that this has been shifted down 3 units. So we're going to tack that onto the end of our function, and voila, we have the equation of the function that has been graphed here. All right, in the next video, we're going to look at graphing a couple of examples of our cosine function. So I will see you then.